Okay, guys. So we're going to continue for how to solve system of linear equation. Still, we are in the system of linear equation. So I'm going to give you. I gave you before how to solve by graph. I gave you also by elimination. So now I'm going to give you solve by substitution and how to solve by substitution here. How to solve by substitution. All right. So substitution technique here and how to solve this one. So now let us take a simple example here. So for example here, if I have, maybe I give you a few examples here. So the first one here, if I have example number one, you have 9x minus 5y equal 1. 9x minus 5y equal 1, that is equation 1. Equation 2 here, equation 2 minus 18x plus 10y equal 1. That is equation 2. So I have two equations here, 9x minus 5y equal 1, and the second one minus 18 plus 10y equal. They ask you to use by substitution here. If I ask you just solve and then I stop here, then it's up to you. You can use elimination or you can use substitution. But let us explain here how to solve by substitution. All right, step number one here, guys. I need to go ahead and solve this one here by for x. What do you mean solve for x? So here again, so you have two equations, right? So I can pick which one is easy to solve for x or y. So the idea here is from this technique or the previous one, how to, because it's two equations and two unknowns, I have to get rid of one of the equation, or I have to make them as one equation in one unknowns, so that I will be able to solve this one. So those here, for example, here, how to solve this one, 9x minus 5y equal 1. So let us, it's up to you. You can write x in term of y. You can pick any equation, either 1 or 2. You can pick equation 1 or 2, one of them, and you can write one variable in term of the other one. For example, here, I could write here easy, I can write x, for example, x in term of y, in term of y. That is, say, in equation 1 or 2. It's up to you. You can pick each one, but it's always you pick the equation which is easy to solve for x or easy to solve for y. So here you have 9x minus 5y. So here both of them indeed is not easy to solve, because you have to solve and you have to divide by constant here. Usually if you have, say, x in front, x 1 or y 1, then there is the one you need to solve. You need to solve. If you have just x here, then it's easy to solve equation 1 for x, right? If you have here y, it's easy to solve that also for y. So here, because you have a number here, so it will be the same. So go ahead and write x in terms of y. Some people, they can write y in terms of x, is okay. So what I'm going to do, I'm going to use, here I'm using equation number 1. So we'll call it used, which means I'm going to use in equation number 1, I try to write x in terms of y. So what is how to write x in terms of y? 9x. I can take minus 5y to the right. So what you have 1 plus 5y. 1 plus 5y. Right? I took negative 5 to the other side, become plus 5y. So now I need to solve that for x. What do you mean solve for x? The number in front, x here, must be 1. So which means I have to divide the whole, both sides by, just by 9. Divide by 9. So because I need to get 1, I need to solve that for x. I call this equation number 3. I put this equation number 3. So what I did, I solve equation number 1. I pick equation 1. Some people can pick equation 2, either or the same. Here I wrote x in terms of y, but some people can write y in terms of x, either or the same. So the idea here is you take one of the equation, I call it used, and the other one here unused here, which means I haven't used it yet. So I'm going to, after I used the equation 1, I wrote x in terms of y, I got equation number 3, I solved that for x, the number in front x must be 1, I put that in the equation unused, which is number 2. I put that, so I put equation 3 in number 2, guys. I put equation 3 in number 2. Then what do you have, if I do that here in equation 2, then what you have, you will have minus, what is equation number 2? Minus 18x plus 10y equal 1. What I did in equation number 3, I solved for x, which means I put x in circle here. Instead of x, I'm just to replace x by number 3. So what do you have? Minus 18. I write, instead of x, you have 1 plus 5y divided by 9. 1 plus 5y plus 9 divided by 9. That is what here? That is my x. That's come from where? Equation number 3. Plus 10y equal 1. 10y equal 1. Then what did you get here? I need to simplify this, but what I really care, it's one equation. What is your unknown? It's become one unknown, which is your y, only y. So if you have one equation and one unknown, it's very easy to solve, guys. It's easy to solve, very easy to solve, because it's only one equation and one unknown. So now I simplify this. How to simplify? Look at, you have 9 here, cancel with negative 18, so you get minus 2. If I can divide 9 by 18, minus 18, you get minus 2. And here 1 plus 5y, and here plus 10y equal 1. Right? And just copy 10y, I put 10y plus 1. Just I cancel 9 with minus 18, you get minus 2. Simplify this, negative 2 multiplied by 1, you get negative 2. Negative 2 multiplied by 5, you get minus 10y. Here you have 10y equal 1. 10y equal 1. Is that correct here, guys? So here you have negative 10y. So if I simplify this, 10y cancel with negative 10y. So what did you get here, guys? I got negative 2 equal minus 1. Negative 2 equal 1. Does that make sense? I got negative 2, negative 10y cancel with negative 10y. What I got, negative 2 equal to minus 1, which does not make sense. That is not true. That is not true here. Negative 2 equal minus 1. So because of that, which means there is no way to solve this system of linear equation. What I did here is not true. Minus 2 does not equal. We know in general minus 2 cannot be equal minus 1. That does not make sense. Because of that, I do not have solution. No solution. I don't have solution. Okay, guys? No solution. So now that is very much the same. But what is the idea? Is two steps here. Step number 1, as you can see, step number 1 here, I wrote. You can pick either from equation 1 or 2, one of them. You just pick one of the equation, we call it used, and the other one is called it unused, which is I'm not using. So equation number 1, here I wrote x in terms of y. Some people, they say, can I write y in terms of x? Yes. If you write y, solve y in terms of x, then you are going to get equation, and that put it also in equation 2. But here, in our case, we replace x. If you solve for y, then you have to replace y. But also you will get the same. You will get numbers, they are not equal, which does not make sense, which means you don't have solution. Which means we do not have solution. Okay, guys? So that is equation. So I give you another example here, guys. Another example here, example number 2. They ask you to solve by substitution minus b minus q equal minus 3. And here 3p and 2q equal 19. All right? Equal 19. So that is equation 1 and that is equation 2. What is my unknown? Your unknown here is p and q. P and q. Right? I need to solve that. I need to get b and I need to get q. So now, which one here? I look for the number that I told you if you have in front 1. Here, look what you have. The number in front p minus 1. The number in front q minus 1. So it's easy to use number 1. So it's easy to use equation number 1 because it's easy to solve either in p or q. It's up to you. If I solve, say, I solve for p. If I solve for p here, equation 1. In 1 here, solve for p in 1. So how to solve this one here for p, guys? I have to write p equal what? When I say solve for b, means the number in front b is 1 and b equal what? Right? So that is the idea. So what I'm going to do from equation 1 here, guys, equation 1, I'm going to go ahead and solve that for b. So I take q, negative q to the right. So you have minus 3 plus, when I take that to the right, you have just q, guys, just q. Minus 3, when I take that, you have plus q. So I need to get 1 here. So I have to multiply the whole thing, each term, by negative sign. If I multiply by negative 1, you get p. If I multiply by negative, you get plus 3. If I multiply by negative, you get negative q. And that is called this equation number 3. So as you can see here, equation 1 used, and this one here, we call it unused here, unused. So I decide here to solve for p. Some people, they say I can solve for q, the same. Solve for q, the same. All right? So here, what you'll do, if you solve for b or q, you just put it in the equation number 2, the one that you are not using at all. So here equation number 3, guys, in 2, we're the one here unused, right? So what did you get? You have 3p plus 2q equal 19, right? So what I solved number 3 here, that is number 3 here, I got b. So I have to take b out, just to replace b by from number 3. So you have 3 open bracket. So you have 3 minus q, and here you have 2q. So that is equal 19. So 19 exactly the same, 2q here the same. Just I replace p here by 3 minus q. That is come from equation number 3. So now I simplify this. What is the good news? The good news, you get one equation and one unknown. What is your unknown? Q. Just q. Here q, q. So it's easy to solve this equation after we simplify. So 3 multiplied by 3 you get 9. 3 multiplied by q you get minus 3q. And here you get 2q, and here equal 19. So now I collect those minus 3q plus, you have 9 here. I can take 9 to the other side. So if I take 9 to the right, become 19 minus 9. 19 minus 9 equal minus 3q plus 2q, which is just minus q. So minus 3 plus 2, you get minus q, right? If I simplify this, what is your q? You get here 10. So I have to get q, not minus q, multiply both sides by negative sign. So what is your q, guys? My q is 10. Your q is 10. Remember, when I ask you to solve for system of linear equation, I'm asking you to get p and q, to get to the two value, p and q. So your q here, I got 10. How to get p? You put that in equation 1 or 2 or number 3. One of these equation is going to give you p. So it's very easy to put it in number 3. If I put that in number 3, it's very easy in one step to get p. So what is that? 3 minus q. 3 minus q. What is your q, guys? 3 minus q. So you have 3 minus 10. Sorry, here I have to multiply by negative sign, so you have negative sign. So you have minus 10. Here you have minus 10. So here you have minus 3 minus minus 10. I put the negative sign between bracket minus 10. If I simplify this, you get 3 negative times negative, you get 10, which is you get 13. You get 13. That is your p. So your p is 13, and your q here minus 10. You can always check before you go, so that if you do mistakes sometimes, you can figure out, or just you try to correct what is your mistake. So what did I got here, guys? I got p for this example, p equals 13, and your q equal minus 10, right? My q here equal minus 10, right? So you can check, put that in equation number 3, 1 and 2. How to check? I put it in the left hand side like this. So you have minus p, check. If I replace p by minus 13 in the left hand side in equation, left hand side in equation 1, what did you get? You get minus 13, right? Minus 13 minus q. What is your q? Your q minus 10. If I simplify this, you get minus 13, negative times negative, you get positive 10. So what did you get? You get minus 3, and that is exactly the right hand side here. You can do that for equation 2. You cannot check only one of them. You have to check both of them. In the left hand side, equation 2, you have 3b. What is your p, guys? Your p here is 13. And here 2q. What is your q? Minus 10. If I simplify this, what did you get? You get 39 minus 20 here. So what is that? You get 19. So that is exactly equation 2 here, 19, which means your solution here is correct. Your solution here is correct. All right, guys? So here, as I said here, I'm just repeating the idea of substitution. You go ahead and solve x by, try to solve here for one of these variable, and then use one equation 1 or 2. You just solve for one of the variable, write one in terms of another, and then you put that in the equation unused here, and then you will get one equation in one unknown, which is very easy to solve. You follow, guys? That is the idea of substitution here. So I give you another example here, guys. Maybe I take this one here out. Just to try to give you what is the example here. Maybe I give you an example where you will have infinite solution. All right? I give you, I think, unique solution. I give you example here. The previous example, it was one no solution, and one I give you what's called here, that is called here unique solution. What I did here, I get two value. That is example of unique solution, because there is only one value for B and one value for Q. So that is unique solution. I give you no solution. So I have to give you example where you will have infinite solution, where you have infinite solution. Okay, guys? So here is one of the example in the textbook. What is the example here? Example number 3. Using try to use this one here by substitution. So I have here, guys, 1 over 2 z, or I can give you even the example that I solved before, guys. Here it also is going to work here, guys. So what is the example I gave you before? I gave you here, all right, the previous example here. So you have x minus y equal 1 minus 2x plus 2y equal minus 2. That is equation 1, that is equation 2, all right? Here they are very specific, solve by substitution. So then you have to use by substitution. You don't need to use other technique or anything, just by substitution in order to show you are able to use substitution technique. Okay, guys? So how to solve that by substitution here? So what I'm going to do here is, if I look to equation 1 and 2, it's very easy to solve. It's very easy to solve for x or to solve for y, right? So I can use here, because the number in front x is 1. The number also in front, that's minus 1. Here you have 2 here. But equation 1 here, it's easy to solve for, say, solve for x. Equation, that is the one I'm going to use here, because it's easy to solve either for x or for y. All right? So let us, every time we solve for x, so let us solve for y. Equation 1, I solve for y. Equation, how to solve for y? So you have x equal minus y equal 1. So I take minus y to the other side. So what you have x equal y plus 1. But here I need to solve for y, which means the number in front y must be 1 and y equal what? Right? Here must be 1 and equal what? So I have to take 1 to the other side. You have x minus 1 equal y. So when I take that to the left, it becomes minus 1. I call this equation number 3. So equation number 3 here, what I did, I solved for y. Some people, they say, I can solve for x. Yes, you can. Here I'm going to solve for y. I solved already for y. This, you have two equations, one used and one here unused. So what I did, I'm going to put equation number 3, where I put equation number 3 in 2. Where 2 here, that is the one you haven't used. So what do you have in equation 2? Minus 2x plus 2y equal minus 2. So here I solve for y, so I have to take y out. I have to take y out, and then I replace y by what you have in number 3 here, which is x minus 1. So you have minus 2x plus 2, and here instead of y, I am just writing x minus 1, which is x minus 1 equal minus 2, right? So what I did, just here is number 2, that is equation number 2, unused here. That's the one I haven't used. So I replace y only from number 3 by x minus y. Go ahead and solve. What is good news? Again, it's one equation in one unknown, which is our x, which is easy to solve. So now, negative 2x, simplify. 2 multiplied by x, you get 2x. 2 multiplied by minus 2, what do you get? 2x, and here 2 multiplied by minus 2, which is minus 2 equal minus 2. So now, as you can see, 2x cancels 2x. What did you get? I got minus 2 equal minus 2. When I solve the other one, you could get 0 equal 0, or minus 2 equal minus 2. So if you get the number equal to the same number, or 0 equal 0, which means those two equations, 1 and 2, they are identical. They are identical. Because what did you end up? You end up minus 2 equal minus 2. So if I take 2 there, so what did you get? You get 0 equal 0, the same. If I get here minus 2 equal minus 2, or 0 equal 0, which means they are the same. So in this example here, which means we have infinite solution. Why infinite solution? Because 0 equals 0 means the two equations, or minus 2 equal minus 2, which is correct, they are identical. They are the same. So because of that, we have infinite solution. That is by using substitution here. Okay, guys? So if you get 0, two numbers, they are not the same. They are not, a number here equal another number here, they are not the same, which does not make sense. Means they are never intersect, or they are never met, which means no solution. If they get does not make sense, nonsense number here, minus 2 equal 1 or equal any number, or 0 equal non-zero, or 0 equal non-zero, which means we don't have solution. But in our case here, if you get 0 equals 0, or a number equals the same number, which means they are correct, and then we have infinite solution. Okay, guys? So that is very much for using substitution. I should tell you also here, guys, if the system here, we call it's terminology here, the system here is consistent, that's terminology here, consistent. If you have unique solution, or infinite solution. So if it has solution, we call it consistent. So the system here consistent. If it has solution, this solution could be unique solution, or you will have infinite solution. And also the system here, we call it inconsistent. The system here is inconsistent, means when you have no solution. Inconsistent means when we have means no solution. I don't have solution. So when I say the system consistent, it has solution. It could be unique or infinite. Inconsistent here when you have no solution. All right, guys. So that is one way here to for substitution here. Some people, they can use a different way. They say, can maybe I mentioned this here as a technique here, and you can pick. Both of them, they consider it here by substitution. You can pick either or, but it's okay. So I give you maybe one example here by other technique here. Other way to solve this one here. So for example here, if I have this example here, solve by substitution. Here, what do you have? You have 2x minus y equal 1. The second one here, minus x plus 2y equals 7. 2y equals 7. Okay, so that is equation 1, and that is equation 2. Here, if I ask you to solve, it's up to you. You can pick whatever you like. Use substitution, use elimination, or by graph if it's 2 by 2. But here, when I'm going to use substitution here, so one way here is, you look for equation 1, go ahead and solve equation 1, it's up to you. You can pick solve for y or solve for x, one of them, solve for y. It's easy to solve for y. Why? Because the number in front is 1. And here, if you solve equation 1, so solve equation 1 and 2 in one variable, just in one variable. You pick one variable. So what do you mean? So equation 1, I have to solve that, say, for y. But if I solve that for y, I have to solve equation 2 also for y. I'm going to explain why. Or if you solve equation 1 in x, you have to solve equation 2 also in x. Let us solve that for y, for equation 1 for y. If I solve, let us pick for y, for example, as an example here. Solve for y. So in equation 1. So what is your equation 1? So just replace minus y and here 1. So just replace those two numbers. So take this one to the right, bring this one to the left. So what do you have? You have 2x. I take 1 to the left, you come minus 1, right? Minus y, if I take that to the right, you get y. I call this equation number 3, guys. What I told you here is you must solve 1 and 2 in one variable, the same variable. If I decide for y, I solve equation 1 for y, I have to go ahead and solve equation 2 for y. If I solve equation 2 for y, let us do that. Solve 2 for y. How to solve equation 2 for y? So you have negative x plus 2y equals 7. So I'm going to take negative x to the other side. So you have 2y equal x, negative x when I take it there, plus x, plus here you have 7. I need to solve that for y, which means you have the number in front, y must be 1. So I have to divide by 2. So you have x over 7 divided by 2, right? X plus 7 divided by 2. I call this equation number 4. So what is going on here, guys? You have equation 3, I solve that for y. Equation 4, that would have y equal this. So I'm looking for a solution. What do you mean solution? Solution means the value x and y satisfy 1 and 2. So here, equation number 3, that is y. Equation number 4, that is y. I equate them. Just equate them. So you have equation 3 equal 4 because the same y. Here the same y. So equation number 3, what is that? 2x minus 1. 2x minus 1, that is your y. Equal to equation number 4, which is x plus 7 divided by 2. So what is the good news here? The good news again is I end up with one equation in one unknowns. Then I have to go ahead and solve that for x. How to solve this one here for x? just multiply by 2 both sides. So if I multiply that by 2, you get 2 multiplied by 2, you get 4x. Negative 1 multiplied by 2, you get negative 2. And here what you have, if I multiply by 2, you get x plus 7. Now, I just solved that. As I said, it's one equation and one unknown. It's very easy to solve. Collect all x in one side, and the constant term, that's called constant term, and this one constant term, collect it to the other side. So if I take x to the other side, what you have 4x. When I take this to the left, it becomes minus x. And here what you have 7. When I take negative 2 to the right, so you get plus 2. So if I simplify this, what did you get? You get 3x. And what I have here, I got 9. So what is your x? 3. I got x here, I need to get y, because there's a system here, means you need to get x and y. So since you have x, you can go back to one of the equation, either equation 1 or 2 or 3 or 4. One of them is going to give you y. If you try to make it for number 3 here, if I put that in number 3 here, that is give you y. What is your y? Your y here, 2x minus 1. So I have to replace x by 3. So what do you have? You have 2 multiplied by 3 and replace x by 3 from here, from the value that I got, minus 1. So what did you get here, guys? 6 minus 1, which is, you get 5. You get 5. So what is the solution here, guys? I got x equals 3 and y equals 5. Again, you can check if the solution correct or incorrect. You can check if the solution correct or incorrect. All right? So that is also considered substitution here. So that is one way to figure out if by substitution, by solving equation 1 in one of the variable, and solving equation 2 should be the same variable. If you decide to solve for y, you should really solve 1 for y and solve 2 also for y. Then you are going to get equation like number 3 and number 4, equate them. Then you are able to solve that for this variable, and then you can use it. It will be easier to finish. That's also, they consider it as a substitution here. So if I ask you use substitution, you can use this way here, or the previous one, as I explained to you here, how to solve this one. Okay, guys. So I think maybe I give you another example here, where using this one here, and then before I finish, so let me give you another example here using the same technique here. So if you have, say, 2y plus 3z equal 1, and here you have, I think that is 3y. Maybe I give you, so here, I give you this one here, guys. All right. So maybe I give you this one, which is 3x plus 5y equals 7. Move this one here. So I just let me correct this one here. So that is the other one, 3 by 3. I'm going to leave the system off when you have more than 2 by 2. You have 3 equations and 3 unknowns. I could give it to you. I'm going to use that on one of the section using different technique, because substitution and elimination and all this technique, it will not be handy to deal with 3 by 3. So let me give you this one here, and then I wrap. So I have here 3x plus 5y equals 7, and here you have 5x plus 9y equals 7. 9y equals 7. All right? So that is one equation here, 3x plus 5y and 5x plus. How to use substitution here? That is equation 1 and 2. As you can see here, if I try to solve that for x, or I solve that for y, either or, because I'm looking for what is the number in front of x here. You have a constant here, you don't have 1. You don't have here 1. So it's up to you now. You can pick x or y. So let us, the previous example we solved for y, let us solve for x this time. So let us solve for x. So if I solve equation 1, so I'm going to solve for x. So solve for x in 1 and 2, guys. In 1 and 2. 1 and 2. So now, when I solve equation 1 for x, what did you get? I need to solve that for x. So what do you have? 7. Take 5y to the right, so you have minus 5y. I need to solve that for x, means your x, the number in front of x must be 1, equal what? So I have to divide by 3. So what is your x? You will have 7 minus 5y. Divide the whole thing by 3. I call this equation number 3. Just I give it a number. Let me call it number 3. Then I have to go solve equation number 2. Also for x, must be the same unknowns, the same variable that you decide to pick. I solve equation 1 and 2 for x. So if I go for equation 2, guys, how to solve this equation 2 here for x? You have 9y, I can take that to the right, so become minus, so you have 5 from 2 here. From 2, I need to solve equation for x. So maybe I write here solve for x. For x, equation 2, guys. So I solve for x, equation 2 here. So I solve for x in equation 2. All right? So I have to solve for x in 2. So you have 5x equal to 7 minus 9y. Just I took 9 to the right, become minus 9y. I have to get x equal what? The number in front x 1. I have to divide by 5. So what is your x? You will have 7 minus 9y divided by 5. I give a number here, let me call it equation number 4. So equation number 3 here, you have x equal something in terms of y. Equation number 4, x, the same x here, because I'm looking for the value x and y, satisfy equation 1 and 2. So I equate 3 and 4. I equate equation number 3 and 4. So because the same x, equation 3 equal equation 4 equal x. So what is equation 3? You have 7 minus 5y divided by 3 equal to equation 4. What is equation 4? 7 minus 9y divided by 5, right? So now I need to solve this one here. What is the good news? Again, here you have one equation. How many unknown you have here? Only one unknown. If you have one equation and one unknown, as I said here, I'm repeating myself, it's very easy to solve. So how to do this? Do cross here, guys. Multiply here this term by 5 and multiply this one here by 3. So let us do that. So you have 5 multiplied by 5. So you have 5 multiplied by 7 minus 5y. And this one equal sign. You have equal sign. I'm just write equal sign. And do the cross here, which is 3 multiplied by 7 minus 9y. Go ahead and simplify this now. Just I multiply this one here by 5. I multiply here by 5. So if you want, you can multiply 15 both sides. You can simplify, multiply both sides by 15. You get that too. Or just do cross like this. So now simplify this. 5 multiplied by 7, 35. 5 multiplied by 5, you get minus 25. 3 multiplied by 7, 21. 3 multiplied by minus 9, you get minus 27. Why? What do you have? The term here mixed between your unknown and constant term. That is called constant term. This one constant term. So what I'm going to do, I collect all the constant term in one side. I collect all my unknowns to the other side. So here, let us take 35. I can take this one here, your y here, to the right. So, and I take the constant to the left here, right? So here I take the minus 25 to the right. So let us do that one by one. 35 equal 21 here, 21 minus 27y. I just copy this. When I take minus 25 to the right, become plus 25y. Then I can take 21, that's the constant, to the other side, because I collect the constant term in the left, on the left. So we have 35 minus 21. When I take that to the left, become minus 21. Now here minus 27y plus 25y. I collect those together, you will get minus 2y. When I simplify this, what did you get? You get just 14, right? You get just 14. Then go ahead and solve that for y. You can solve this one here for y. So what you have? You will have 14 divided by minus 2, divided by minus 2, both sides. So what did you get? You get minus 7. So your y here equal what? Minus 7. Remember, I need to solve to get x and y. What I did here, I got y. So now to get x, it's very easy. You go equation number 3, equation number 4, or 1 or 2. One of them is going to give you your x. So easy here to put it in number 3, guys. If I put that in number 3, what is your x? You will have your x here is 7 minus 5y divided by 3. So I have to replace y by minus 7. So you have 7 minus 5. What is your y? Minus 7. I put it between bracket because it's a negative number, divided by 3. If I simplify this, negative times negative, you get positive. 7 multiplied by 5, 35, divided by 3. So what did you get here? You get 42 divided by 3. That is your x here, right? If I simplify this, what did you get? You will get just 14. You get your 14. So here your x is 14, and we figure out your y minus 7. So what kind of solution here you have? We have unique solution. We have unique solution means it's only one solution. Unique solution. And we say the system is consistent here means it has unique solution. And you can check what you are doing correct or incorrect by taking those two numbers, as I explained to you. You put it in one and you put it in two, then you are able to get to check the solution correct or incorrect. All right, guys? So check that. I leave that to you to check at home. I think that is very much my substitution technique here. So you have to give attention. If I ask you by graph solution, then you have to use by graph. If I use by elimination, you have to use by elimination. If I give you substitution like this, then you can use whether, as I explained right now, you can use this one here or that. When I start the substitution technique, you can use either or. It's called also substitution technique. All right, guys? I will stop here. Thank you. Thank you. Have a good one.